Good afternoon, everyone. I'd like to welcome you all to the SolidWorks tutorial. Today, we're going to be working on the basic part modeling task number 38, which is the manifold. And below here, we have the isometric view of the 3D model we want to design. And we have a notice here that all of the given dimensions are in inches. And I'm going to briefly describe the design approach we're going to take towards this task and just outline the key features and things we have to consider before we open up SolidWorks. So the first thing we should take note of is the draft angle. And so this angle here basically means that each of these extrusions, right, are drafted inwards 5 degrees in every direction. And there are many ways to realize that in SolidWorks. The first one would be to just use an extrusion and include a draft in the extrusion. And the other method would just be to extrude the drafted profile. So you would just draw this line at 5 degrees and then extrude it. And then in the other view, you would also draw the line at 5 degrees and then extrude that cut. Depending on how complex your model is, you can choose either approach. But for this task here, we're just going to extrude each of these bases at 5 degrees. Now, the other features that we have here are the two holes, which are directly through the pod, as well as the hole here on the bottom face, the central hole, and the top hole at the top here. The other two features are the two extruded bases here, which are very important because these two extrusions are perpendicular to the inclined face. So when we do design them, we have to consider that as well. And one last thing to note is that due to the draft angle, this hole here is not exactly in the middle of this face. So that's going to be a key part of the design. But for the main part and the main features, we know that these three extrusions here are basically symmetric about a midplane, and that's where we'll base our part off of, and then we'll only add this hole and this hole. We'll add all of the extra features after we come up with our base. So as usual, the first thing we want to do is come up with a base upon which to build on, and then once we have our base, we'll add the cuts and the further extrusions as required. We also have the dimensions of the extrusion on the side here, and that's just something we'll be referencing once we start coming up with these extrusions. So I'll just leave this on for a little while I open up SolidWorks. And yeah, here we are. So the first thing you have to check, as you always, is that you're in the correct unit system. Once that's been corrected, we can now begin our sketching. So we're going to start with, I'm going to add in these bases sequentially, and we're going to start with the top base. So the smallest base has these base dimensions, and we want to extrude it downwards essentially. Oh well, we'll extrude it from the bottom going up at 5 degrees. So we'll offset it at the depth, and then we'll just click the up to surface feature, and then we'll include the draft angle of 5 degrees as requested. So what this means is that the base that we've just drawn would be at the bottom, and then we draft it 5 degrees in each direction going upwards. And we can do the same for the next rectangle, and we can just sketch it on the same plane and add the offset as required. And so the rectangles don't have the same center per se, but we know that the centers of the rectangles are in the same plane, which is namely this one here. So we have to align it in the correct plane, and then we add the dimensions for the second base. And to fully define the second base, we have to relate it to the edge of the top base. So we need to add this dimension here to relate the base of the second part to the base of the top part. And we'll need to use the same offset rule that we used as before. And we'll just use up to surface as we did before as well. Make sure your merge result option is ticked, and there you have it. Now we want to add the third extruded base using the same procedure. And we want to now add the reference to between this base and the second base, and we know that it's the distance from the second edge to this outer edge here, just 10.4. Okay, and we're going to use the same offset rule to add the dimensions of the extrusion. Then we'll add the same draft angle as before and make sure we merge the results. And as you can see here, the faces are indeed at some inclined angle, which is 5 degrees. Now that we have our bases, we're now gonna add our extra features. And the first one we're going to add is the hole on the top extrusion. And as I mentioned earlier, this hole is not centered on the base, but it's more or less centered off the top. Well, it's not centered, it's just the dimensions are given. I'll just double check that with reference to the top. So it will be in the end offset quite a bit. So I'll just sketch it freely in the beginning, and then we'll position it accordingly once we've fully defined the sketch locally. So I've added a construction circle here, as well as construction lines for the center point of that circle. I'll add in the vertical and horizontal lines as well as the actual constructed arcs. It would have been, of course, possible to center your piece at the center of this hole, but then you would also just need to make sure you would realize that the rest of your part would be offset from that origin. Now I'll just add this final arc here. Yeah, that's the general shape we're going for with our hole. Let's add the constraints between the lines, so that they're collinear and they're symmetric where applicable. And yeah, we need to make sure that the arc endpoints are coincident with the line endpoints. Yeah, and SolidWorks usually shows you or highlights that you actually have an enclosed volume or surface rather. Now we have the inner geometry geometrically constrained. So now we just want to dimension it to fully define this part. Oh, that kind of blew up our sketch, but we'll fix that pretty quickly just by moving parts a little bit. And yeah. Okay, so we just need to realign them like this first, then just add the dimensions up accordingly. You know that this width here is 0.8. Right. This clearance here is also given as 0.8. Okay. Now we want to position our main hole. We know that it is. So we have the front side of our part and the back side, right? So we know that from the back side, it has the position of 4.5. And from the left side, it has the position of 3.3. So do we have to add those positions to the sketch? And these distances are from the top edges and not the bottom ones. 0.3 from the left side and 4.5 from the back. And yep, so now there we have our hole fully defined, and I'll just hide away some of the other things so we can see the offset between this origin, the whole origin, and the geometric center of the extrusions. There's a slight difference between them. Now we just need to add the feature, which is an extruded cut at up to 3.4-inch depth. So there's our first extra feature. Now I want to add the rest of the features that we'll need. So I'll just show. The next thing I'll add is the central hole, which is on the surface of the bottom extrusion. For that, I want us to use the hole wizard because it's very good for counterboard holes. In this case, the counterboard hole dimensions are given as well as a position relative to the edges. So we're going to use the legacy hole and specify that it's counterboard. Going to add the functional diameter as 1.6, and then add the counterboard diameter and counterboard depth. The depth of 1 here actually belongs to the counterbore, and the rest of the hole is a through hole throughout the part. So what we can do is just change the end condition to through all, and in that case the depth of the hole is irrelevant. Now I want to position our hole. I just have the plane, and the plane's here for reference. We know that it's in the middle of the part, so we just align it along the plane first, and then we'll add the distance as required here from the edge of the second extrusion. Which is 3. So that that 4.7 is unnecessary once you already, the 4.7 is only necessary if you do not use the mid-plane relation. Okay, so now we have our profile here. Now we just need to add the features along the sides. The next features we're going to add are the 2 holes through the third extrusion. So these are just two holes of matching diameter, and we're just gonna have to specify their size and their placement. So here I'll just add a construction line between them to ensure that they're on the same line, horizontal line, and I'll add an equal relation for their size. Now the vertical distance between the base and the holes is 2.2 inches. One of these holes is 3.8 inches from the front, while the other is 30 inches from the front. So I'm just going to add a construction line, which will represent the front of the part, and then I'll add the respective dimensions for each of them. For some reason here, the vertical line is not fully defined yet, so we'll just make it coincident with the point at the edge that we wanted to refer to. So this one would be 30 inches. And this one would be 3.8. And now we need the vertical distance from the base to the center point of the holes. And that's 2.2. And now our hole profiles are fully defined, so we can realize them through the extruded cut feature. And if we just use the through all in both directions, then yeah, we cut all of the material out along those directions. And here we have our view, our part in the original view, and here are our holes as well as the other features. So now the remaining two features are the extrusions that we need, and for those we would need to add a bit of reference geometry, because as mentioned earlier, the extrusions are we have to extrude them from an inclined plane, which is perpendicular to this surface here. So the first thing we need is a plane offset from the base, right, which is where we'll be starting our sketches from, and we'll have to add two reference axes, which just represent the edges along the lines. So before I proceed, I'll just rename everything so that we can be a bit clear as we talk about the parts that are important. good practice to always give your features meaningful names. So in case someone else wants to look at the part later, or in case you want to revisit a part for updating and you only want to update certain features, for example. So now we have our first bit of reference geometry, which is the vertical offset plane. So it's 2.4 inches above the base. And then the next things we want to add are the axes, which are essentially the imprints of the line and the base. So we need these reference axes because we want to create a plane inclined to the current plane that we have by 5 degrees. So now we have our front axis and our side axis. Now to create our construction planes, we'll need to reference each of those appropriately for each of the sketches. So to create the front sketch plane, we'll need to specify the angle relative to the horizontal plane as 105 degrees. And we need to make sure that this plane is coincident to our reference axis. And there we have it. So this is our front sketch plane. So to define this plane, we need the axes, right, which is basically the reference line or origin of our plane, as well as the horizontal plane, in order to have this angle of inclination. So we're going to do the same here for the second plane. We'll make sure it's coincident to the side axis, and we need to specify the angle of inclination to the horizontal again. And the normals will either point downward or upward. You can just flip that. That just defines which side is positive in terms of extrusions and the like. Okay, and now we finally have our sketch planes for extruded bases, and I'll just hide the primary planes while we come up with our sketches. For future reference, if you would like to have a look perpendicular to a custom plane, it's Control 8. Now on this plane, we draw the profile of our extrusion. So we start off with the baseline, and from the midpoint of the baseline, we erect the symmetry line. And now we just give the basic outline of our profile. We'll just mirror the left-hand side about the symmetry line.
and we'll just have to dimension the left portion of our extrusion. Add the base width, and we add the overall length here. And we add the chamfer angle, 45 degrees, and okay, it's a bit blown up now, but we'll fix that pretty easily. Engine, eight, the width of the narrow part, 3.6. Yeah, and we still have to position the part. Well, as I believe at the vertical distance for the chamfer. Oh, no, okay, that's so we still have this degree of freedom along the line. So we just need the relationship between the extrusion and the leftmost edge of the part, which is that we have the distance of 1.6 inches between them. And that fully defines the outline of the sketch. So now what we want to add before we extrude the base is the hole. We know it's along the symmetry line, has a diameter of 1.2. I'll just add that quickly. And it's at a height of 3.2 inches from the base. Okay, and there we go. So that's the final shape and form of our extrusion. So now we just have to extrude it at a thickness of 1 inch. So this 1 inch, as I mentioned earlier, not a vertical thickness, it's just a thickness along the extruded plane. And we always make sure you tick the merge result option so that you still have one part. So now that's the front extrusion. And now in order to create the side extrusion, we are going to use the derived sketch feature. So the side extrusion is basically the same profile, or the same feature rather, just placed in a different position. So when you use a derived sketch, that's the benefit of it, in that it takes the profile you previously defined and links it. So to use it, we just need the sketch and the new plane in which we want to place the sketch, and we click Insert Derived Sketch. So now I'll just hide up everything else here. So now we have a new sketch here, which is based completely off of our previous sketch. And to fully define this new sketch, you would only have to position it within its new within its new space. But then for us to modify the sketch, we have to underive it. So for today's tutorial, we're going to underive the sketch and then reposition it. And to do that, we're going to use a reference point here. This point will represent the corner of the surface, and we're going to essentially rotate the sketch as it currently is and then translate it back to where it should be along the side. So we use the Move Entities option and first click Rotate. And we want to rotate the profile. So we click that and we include the inner circle. The center of rotation should be specified as our corner point at 90 degrees, and we have it there. Now, what we need now is to, now that we have the sketch oriented in the correct way and at the correct inclination, we want to move it to where it should be, which is 21.8 inches from the front. So as you see here, I can freely drag it and move it along because it's underived. If it was derived, then we could move it, but we could not alter the dimensions. So now we just need to re-add the construction line for the symmetry point, and now just add the relations relative to this instance of the sketch. So similar to the previous one, we need the collinear relation. And we need to reapply the symmetry relation, but might have to do that either element by element, or you can also set the two sides of the part equal to each other. I'll just re-specify the base dimension. The nominal width. And yeah, can fully define the circle as well. This should have been 3.2. Yeah, the full height should still be 5 inches. So I'll add that in as well right here. Right, re-add this chamfer as well as the chamfer distance. And we have it fully dimensioned, but we still need to add the geometric constraints. So instead of applying the symmetry directly as previously, here we just use the vertical alignment of the points, and we see that there's still a slight degree of freedom here. We still in the end need the symmetry relation between the horizontal lines. Hmm. Ah, there. Okay, so we still need the full symmetry condition. So now the top is fixed, but not the bottom. Now at least our shape is fixed. So last thing we'll do is fix the position of our extrusion with the length of 21.8 inches. This edge, and we need this nearmost point. There we go. We see it's underdefined here because we still have the original construction line. We do not need that anymore, so we can just go ahead and delete that, and we'll see that our sketch is now fully defined. So now we can just make our final extrusion at the same depth of 1 inch, and there we have it. So now we've finally completed the part, and it took a few more steps. I overcomplicated the revision of the second sketch, but that was just so I could show how versatile the use of the derived sketch feature can be. Of course, if you want your items to stay the same size, then you do not need to underive the sketch. But for versatility sake, then yeah, you can just underive a sketch and redefine the relationships. Right now, I'll just use the evaluation feature to show the difference between the vertical height and the inclined distance. And yeah, so this is the part, and I'll just show the mass properties now quickly. And these are the values you should have. If you look at the surface area and the volume, should have similar values. But for now, that's it for this tutorial. I thank you all for your attention and wish you all a good day.